Okay, so we are going to start now. Thanks a lot for joining today. My name is Eduardo and Ido here. We are the maintainers of Ploomber. So the way this will go is we'll be explaining this. Can you hear me? Okay, great. So we'll be running this notebook. Most of the commands are for the terminal, so I would recommend you to open a terminal and then just run the commands. That's going to help you to remember the details. Otherwise, just like if we keep running and running, it's kind of easy to forget. So just to exercise your muscle memory, please type the commands in a terminal. A few of them are in Python, but I'll let you know if you have to switch. And it's going to be mostly a combination of running a few commands, well, actually explaining a few things, then running a few commands, and there would be a bunch of exercises for you to do a few things and start learning the framework, and then we'll help you to get through these exercises. Okay, so let me first get some background on why we built this library and why is it useful, kind of the use cases. So I spent like about 6 years working as data scientist, and Ida spent I think the same time, right? Like 6-7 years working in data engineering. And one of the biggest issues that we saw is that it's really hard to take whatever code you put in a Jupyter notebook into production. And production means many things. It can be, I want to schedule a report, and then I want the report to like send that to someone, or it can be a model running in production, or anything in between, really. And there isn't like any reason why we shouldn't try to improve this workflow. Like what we've seen with most researchers and companies and data teams is that they take these notebooks, they essentially prototype in a notebook, then they clean up the code, which makes sense, right? We should always clean up the code. But then they start refactoring this code into Python classes and functions. In some cases, it makes sense. In some other cases, it feels like we are just trying to fit our code into the target platform, like Kubernetes or Airflow. And there isn't any value when we are forcing or we are modifying things just to fit whatever platform we are using. So that's the main motivation for Ploomber. How can we use the tool that we like the most? We like Jupyter notebooks a lot, and use them in a much more maintainable way, so we can deploy these notebooks or make them more maintainable. That's really the most important thing. And we'll start with legacy code. So I'll show a notebook that I already have to show how you can get going from an existing Jupyter notebook. But this really applies to, like, even if you're starting a new project, you can start this from scratch. But in many cases, you may already have some notebook that you want to clean up, like create a more maintainable project. So let me open that one. So I'll go to, and please make sure that you are in the root folder of the repo. So you should see the material. Now, I made a few changes last night, so please make sure that you sync with the upstream. So with my repo, because if you clone my repo, just do git pull. If you fork the repo, then you need to run a different command. I sent the command last night, so just go to the Slack. And you'll see, you should see the same files that I have on the left. If you don't, I'll just run the brief explanation, and then we can help you. All right, so let me open the existing notebook. So I'll go to material and then notebook. Okay, so on your left, you see what's a typical Jupyter notebook. You see that I'm importing a bunch of libraries, so like the typical libraries. Like this is a machine learning notebook, but this can be anything. It's just for an example. I'm importing a few libraries. Important thing, I'm naming the sections in my notebook. So that's like an important detail for the next step. We can put any names that we want, but I have a load section. I'm just importing my libraries. The details for this notebook are not that important. It's just to set the example, and then you'll see what we do with this notebook. I'm just cleaning some data. And then I'm cleaning that data. So I'm getting that data and then applying a few filters with pandas, then plotting that data. and then a new filter, and then a new histogram. Then I am training, well, actually splitting my data in training and testing. So you see that I'm taking my data frame, and then that's my X, and then this is my Y, and using train test split, and then that gives me my training and testing. So that's another section. Then I am training a linear regression. So I just import the model and then fit the model and then generate predictions and have an evaluation chart. And same thing for a second model, random forest, like the same idea, import the model, fit the model and create a chart. So a pretty simple thing. Let me run so you can see that it works. And this is just like some typical example of something that you may have already for any use case that you have. So the only requirement for the next step that we are going to do is to have these markdown headings. You can see this is an H2 heading. And you can see that this is running. So I ran the whole thing. All right. So what's the issue with this notebook? This is actually a short notebook, but in reality, when we are doing a real project, this may have, so this one has like 20 cells. Yeah, exactly 20 cells. A real one or a more complex one would have maybe like over 100, if not more. And then things get really complicated when we have a lot of code in a single file. To get started, it's hard to collaborate with someone else if everything is on a single file. It's hard to test. And if we make one mistake, we may start having some hidden state, and then the cells output doesn't make any sense, and it's just like really painful. So what we do is, the idea behind Ploomber is it's a lot easier to manage small things than a big notebook. So that's what we're going to do. We're going to break down this large notebook into something that's easier to maintain and collaborate. And we're going to do that automatically. That's the important thing. Because if we go the manual route, it's going to take us like 10 minutes maybe for this one. Maybe less than that. Maybe let's say 5. But if it's a long one, it's going to be like 30 or more. Maybe we make mistakes and we don't want to do that. So let's go the automated route. So that's the very first step in this in the workshop. We are gonna go to this. So I'm in this cell, right? Is the large the font large enough? Can you read it? Okay, great. So let me go now. I'm gonna be typing the commands on my terminal. Just so. I recommend you to do it as well. So the first thing is I'm going to move to my material folder, and you'll see that I have my notebook, the notebook that I just showed, and then I need to run this command. So this surgeon library is also from us. It's something that we did to help people adopt Ploomber. So the way this works is it's going to turn your big notebook into mini files. And it's going to figure out the dependencies and all that stuff. And we did that because when we were talking to people that wanted to use Ploomber, they told us that they didn't have time to refactor their notebooks, or they didn't want to risk themselves breaking the code. So we did this so they don't have those issues and they can automate the process. All right, so let's see how we do this. We do surgeon, and then we use the refactor command, and then we pass the path to the notebook. So you see that I'm doing surgeon, refactor, notebook I, pi, and b. And then there's a few configuration parameters. You can actually skip these, but these are useful because you may need to make a few changes to the notebook after you refactor it. Passing these flags is going to help with that process. So the first one is I'm going to use the Parquet format for some of the variables, because remember, since we're going to break down this into multiple files, now we need to store the output of the first section and then load it in the next section. And you'll see this in a diagram. And the next one is the file format. So if I don't pass this argument, the output is going to be a collection of I, pi, and b files. which is fine. But we also have a second option, which is the one that we recommend the most, that is using PI files. And thanks to the integration that we have with Jupyter, you can open PI files as notebooks. Now, what's the benefit? The main benefit is that you can use GitHub to manage these files, because if you push the Jupyter notebooks to GitHub, then it's a bit difficult to manage and to review the code. It's just like a simple trick to make this easier. But if you feel comfortable with Jupyter notebooks, you can skip this part, and then the output would be IPyNB files. But let me pass this flag, and then I just type enter, and you'll see a bunch of output here, just like next steps. But since we are in this workshop, I'll tell you the next steps. Okay, now let's see what we have in our folder now. So this is new. This file is new. This tasks folder, and also the requirements. So a few things happen here. Surgeon extracted the dependencies, and it generated this file for us. But you should already have the dependencies. If you don't, please do pip install our requirements. Actually, I'm gonna do that. It shouldn't install anything because I already have everything. But if you don't, please run it. And then let's see what this tasks folder has. We see a bunch of files, and if you pay attention to the names, you'll see that these are the exact headings that we have in the long notebook, right? So we have clean, actually load is the first one. Load, clean, train test split, random forest, and linear regression. And it's just copy pasting the code and then adding a bunch of cells at the end and at the beginning so we can communicate this. But it's the exact same code. Now, since we broke down this into multiple pieces, now we need to essentially define how we are going to run this thing, because all of a sudden it has a bunch of files. So if you click here or go to Material, Pipeline YAML, you'll see that we have this new pipeline YAML file. And this is the most important file in any Ploomber project, because this is where you specify the steps in your pipeline. Now we are talking about pipelines. Before we were talking about the notebook, now we are talking about the pipeline. And a pipeline is just a bunch of steps. It's just a fancy way of saying I have a few scripts that I want to run. And we are going to get through the details of this in the next section, but the important thing to see here is that this pipeline YAML has two required things for each task. The first one is the code that we are going to run, and the second one is the output of each task. Now, the command that we just ran generated this file automatically, but if we were to start a project from scratch, we would create a clean pipeline YAML, like an empty file, and then start typing things. But since we started with a legacy notebook, we have this already. Okay, now let me run the second command so you see the dependencies in this task. So I'll run this command, Ploomber plot. I'll just copy it. So it's a Ploomber plot /backend D3. So we are gonna see a graphical representation of our pipeline, and you'll see that it's the same thing that we had earlier. So pipeline HTML. Now, if you open this thing, you'll see that this like message, just click on Trust HTML right here, and you'll see the plot. So let's see if I can make this larger. Maybe move this here. Okay, so you see a bunch of things here. It's exact same the exact same structure that we had already. So I'm loading some data, then I'm cleaning that data, then I have train test split, and then this is important. This is Ploomber is figuring out the dependencies, and it's trying to parallelize as much as it can. And it figures out that if I'm training two models and both depend on the training data, they don't really depend on each other, right? So I can run them in parallel. That's why we have this structure here. And this means that when we run it locally, we can run both in parallel. And maybe for these two, it's not a big deal, but if we had 100, then that would make a big difference in terms of runtime. And we're also going to show you how you can export these to a larger infrastructure like Airflow, SLURM, Kubernetes, Kubeflow. And this type of structure helps a lot if you are doing running a lot of things at the same time. Okay, now let's see what's next. I'm going to explain in more detail the pipeline YAML that we generated. So let me just run this, and this is going to print the contents. Well, there isn't actually much to say here, apart from what I mentioned earlier, that we have the source, so the script that we are going to run, and you see that I have source load py, clean py, train test split, and then the other two. And then below the source, I have product, which is the output. And I have two things for it. Well, this is actually important. I have two things for each task. I have this data, so the data that I'm loading or cleaning. In this case, it's actually 4 files. But I have another thing that's common to each task, this NB thing. And you'll see this is a Jupyter notebook, and you might be wondering, why do I have a Jupyter notebook as an output? The explanation is that each run, so we are going to orchestrate the execution of this whole thing. Each run is going to generate a copy of each file. So essentially, when we run our pipeline, Ploomber is going to convert this Python file into an IPyNB file and then run it. And then every chart or every table that we have in the code will see a copy. Now, this is important if we are running many things, or we are maybe running some experiments and we are modifying a few things. We can keep a historical record of each execution, and then we can compare those executions. And this is also an easy way to generate reports, because we can change the extension of this. We can put like PDF or HTML, and then we get reports for each task for free. So that's why we have this notebook as an output. All right. Any questions until here, or any issues? All right. I'll go to the next section then. Now, if you want to manage your pipeline, then you have to use the command line interface, right? And in this section, I'll explain the most important commands to manage your pipeline. Let me find the right section. Okay, here. Now, if you have everything installed, you can run Ploomber help, and you'll see that we have a bunch of commands. I'll explain some of them, the most important ones. But after the workshop, if you want to learn more, well, of course, you can go to the documentation, but you can also do the / help to see other things. Okay, now let's run the first pipeline. You'll be running your first Ploomber pipeline, and all you have to do is execute Ploomber build, and then type enter, and you'll see this loading pipeline output. Let me make this wider, and then the pipeline will start executing, meaning each notebook, each short notebook will start executing, which is what you see here. You see it's going, it's executing the 4th notebook right now. Then it's going to execute the last one. The parallel execution is not enabled yet. That's why it's running things one by one. Okay, I have an issue with the size of my terminal, but it executed correctly. And actually, if I go to output, you'll see this new folder, output, and you'll see all the files, essentially all the files that I show you in the pipeline YAML. These Parquet files and the Jupyter notebooks, you'll see them in the output folder. Actually, let's open one of them. Let's open Brandon Forest. You'll remember, this is the output notebook. This is not the source. This is the output notebook. So you see that it's executed in order, and it has the outputs. So now you can review your results, and maybe you change some parameter in the notebook, you rerun, and then you can compare those notebooks. All right, so now that's for the execution of the first notebook. Let me go to the next step. Now you can also use Python to execute the pipeline, and that's useful if you have extra logic. Maybe you want to, I don't know, maybe check a server, or you want to do a few things before you execute your pipeline. So everything that I'm running on the terminal, you can also run it from Python in case you need to add any extra logic. And that's what I'm going to do now. You can run this from the notebook. I'm importing the Ploomber package and then passing the path to the, you can see here, Ploomber.spec, backspec, and then initializing it with the pipeline YAML file, and then converting that into a DAG object. So the DAG object is the internal representation. And then this returns me a DAG object, and then I run build force equals true. I'll explain why I need to pass force equals true in a second. Then if I run this, the same thing is going to happen, the same thing that I run on my terminal. You'll see that it's running the clean task. You can see the progress here. Now the train test split. Now the random forest, and then the last one is going to be the linear regression. All right, we can ignore these warnings. Okay, now let me show you something here. When we are doing data analysis, in many cases, we modify a tiny part of the code and we want to update the results. So let's see what happens if I just run the same command that I ran before. So you see I'm trying to run Ploomber build, and it doesn't run anything. You see that in this column called run, it says false, 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 false. That's because I haven't modified anything in my pipeline. So there isn't anything to run, because if I run the code, it's going to produce the same output, or roughly the same output, right? Because we may have some maybe statistical testing or some processes, and the output may change. But ideally, we should have the same, at least for our own definition of the same, it should be the same output. Now let me modify one of these files. And this is where I'm going to show you that I can open Py files as notebooks. So I go to tasks, and let me modify train test split. You see here that it's a .py file, right? If I double click, it opens as a notebook. So it behaves like a notebook, but it's a Py file. Now let me add a print statement, just so I have a different output. Hello from SciPy. Okay. Now I can run this interactively. I can come here, and this is a really important part of the data analysis process, right? Running things interactively, see how they change results, and let's imagine that I'm just like experimenting with my code. But at some point, I want to rerun my pipeline, because first I want to make sure that if I run this notebook from top to bottom, it runs. Because when we are experimenting, if we move cells around, we may break it. But most importantly, I want to make sure that all the dependencies of this notebook are also executed. And let's go back to the diagram. I modified, well, it's a bit difficult to read, but this is the one that I modified. And you see that it has two dependencies below. So now if I go to the terminal, and I run Ploomber build again, now Ploomber will see that we changed one of the tasks, and this is actually the first one that it runs and then it goes and executes the dependencies. But it skips the ones that go before that notebook. So right now it's executing 3 out of 5 tasks, and it's saving some time. You see here in the summary that it skip, load, and clean. Now here we only have 5 notebooks, and we are probably just saving like 10 seconds because this is dealing with a really small data set. But if we have like maybe let's say 10 gigabytes of data, and each notebook takes like 50 minutes or 30 minutes, then we are saving a lot of time. And that's really important for this iterative process that any data analysis project involves. And now let me show you a new command. Let me go to the terminal. If we do Ploomber status, we'll see a summary of our pipeline, and you'll see that here, right? We have the first column is the name of the task. The second one is the last time we ran it. So you see 4 minutes ago, 4 minutes ago, a minute ago. These are the latest ones. 58 seconds, 50 seconds. Then if it's outdated, meaning has the code changed or any dependency has changed, the output files, the doc strings, the notebooks don't have any doc strings right now, so this is empty, and the location. So this is just a summary. This is important if you have a large pipeline and you want to locate files or you want to see the status of the pipeline. Okay. Now, let me see how much time we have for this section so I don't go over time. I think we have an hour. Let's see. Yeah. Okay. All right. Let me just see what's left so I can make sure we finish this section on time. Okay, cool. Now, let me tell you one important thing about the integration with Jupyter Lab. So we have an integration with Jupyter Lab that allows you to run things without fiddling with the output path. So I explained before that since we have multiple notebooks right now, we know how to pass the output of the first notebook to the second one, the output of the second one to the third one, and so on. But if you install Ploomber in the process that runs Jupyter Lab and then run and then you open one of your tasks, and when I say tasks, I mean anything that appears in the source section of your pipeline YAML. Let's actually open one. Let's open. I actually have one open, so I'll just click on this one again. You'll see this new cell. Now we don't code these ourselves. This is automatically injected by Ploomber when you open the file. And what it contains is the input path. You see that the upstream, meaning the dependency, is the clean task, and I have the paths here. So then I can use them in my code, and I don't have to hard code any paths too. So that's good. And if I change anything in my pipeline YAML, then I'll see a different set of values here. And I also have the output path. So I should respect these values and use this when I store my output. So you'll see that in my code, when I load my input data, I'm referencing, let's make this larger. I'm referencing the upstream variable. So I'm loading my input from this variable. And when I store my output, I am using the product variable. So we follow what we said in the pipeline YAML. The product, and we use product here. And then the other one is upstream. Now this allows you to go back and forth between your notebooks because I can just open the random forest one and I'll see the same thing here. This is what we call the injected cell. And I can just run things. I don't have to add any code to make sure that I'm loading the input or anything. And you see that I'm moving around between files. And it kind of feels like a single notebook because everything's connected. But it's not a single notebook, it's actually 5. And they are actually Py files. So, we kind of tweak a few things to make this work. But it makes it really interactive and easy to use. You don't have to deal with the details. Now, I modified a bunch of things, just carelessly open unexecuted files. But thanks to Ploomber, I can just come back to a terminal and execute Ploomber build, and it will figure out what changed and execute accordingly. And I actually changed the load py file, so that's the first one. And in consequence, it will have to run every single step. So the Ploomber build is kind of a safe place. If you feel like things are not working, just go to Ploomber build, execute it, and it will figure things out. All right, let me see. One important thing. In some cases, depending on which Jupyter Lab version you are running, you may not be able to open py files as notebook, at least not with this double click trick. So if that happens to you, you can do right click on it, open with notebook. If you don't see this option, then Ploomber is probably missing from your Jupyter Lab. Now, one thing that might be happening, and this is a bit like, well, not complex, but it's like a detail in Jupyter. Like many users sometimes are not able to do this, and it's 90% of the time is the same reason. When you install Ploomber, make sure that you install it in the same process that you where you execute Jupyter, meaning you do pip install Ploomber and then you call Jupyter Lab. Because sometimes if you install Ploomber in the kernel, in the process that runs the kernel, you won't see this thing. And this is especially, this is a problem mostly when you are running a hosted version of Jupyter, because in those cases, in many of those cases, you cannot run, you cannot install new packages in the Jupyter process. You can only install packages in the kernel. So that's a bit of difficulty, but we found that many users were struggling with this, and we added one command to manually inject this special cell. And actually, let me recap and explain again, because this is an important detail, what I explained about the injected cell. So when we open a Jupyter notebook or a py file that we want to use as part of our Ploomber pipeline, we have to tell Ploomber which notebooks we want to execute first, what we want to execute before we execute the one that we are editing. So let me open, let's say, linear regression. And then you'll see this special upstream variable. This is how we tell Ploomber that it should run one task before, or actually it can be many. Here it's just one. With this upstream equals train test split, we are telling Ploomber that it should execute train test split.py before it executes this one, because we want to use the output of train test split as an input. And this is how Ploomber figures out the dependencies. And I can probably add more things, like another and one more, and then it would be 3 dependencies. These notebooks don't exist, so I'll just delete them. Right. And once we specify this cell, then Ploomber knows what to put here in the special injected cell. So let me go back to my main notebook. And just to recap, so upstream equals the name of the notebooks that we want to execute before. And this is what we code. And then what Ploomber automatically injects is this, remember what we call the injected cell? It figures out the content of this cell based on what we told we wanted to execute before. Now, this happens automatically if we are using Jupyter Lab, but many people like to use PyCharm or VS Code or any other editor. If you don't use Jupyter Lab, you can execute this command, and this will inject this cell based on the dependencies that you specify. All right. Any questions until here, or comments? Should I go back and explain anything? Anyone having issues with the setup? Nope. Yeah, so so let me see if I understand correctly. So you're saying I add something here. Yeah, so this is what you edit, and let's say you need a new value or new variable, new one, and let's say new, let's say CSV. Now, if you, let me actually save this. This is train test split, so let me open that one. You see? New one. So this is the benefit of this is that you don't have to keep track of this. It automatically updates. But that's a good question. And if you are not using Jupyter Lab, then you have to run it manually and run this one. Now, I think this is actually a good exercise. Let's see that we we made a mistake. We said that we were going to generate an output, this new one output, but we forgot to save it. So let's run Ploomber build. And that's why I mean that Ploomber build is the safe place, because it verifies a bunch of things. And we'll see the error here. Okay, so we have an error, and it says, error building task train test split. The task ran successfully, but the following products are missing. So it's telling you, you told me you were going to generate new CSV, but when I run your notebook, it's not there. And this allows you to kind of keep things in check. And then you have two options. Maybe you forgot to store that file, or maybe you don't need that output file. So in our case, I don't need that. So I'll just delete it, come back and execute Ploomber build. And now it won't complain. And you see that it's starting from train test split. It's not running what happens before. That's a bit hard to read because of the font size, but you can see that load, clean, these last three are not executed because we didn't modify the code. Okay, let's go back to the notebook. All right, now let's learn about pipeline parametrization. This is, I think this is the last, yeah. Okay, this is important and really, really useful for your projects. So in many cases, we want to run the same pipeline with different values. Maybe we are analyzing, let's say, geographical data, and we want to run the same analysis for different areas. Or maybe we are analyzing financial data, and we want to run the same analysis for different companies, right? It's a pretty typical use case. Ploomber allows you to parameterize your pipeline so you can run the same thing with different values. And there are a bunch of ways to do this. Let's go with the simplest thing. And the use case that I have here is having a sample parameter. Given that Ploomber allows you to run your pipeline with a single command, it's and I do this with all my projects. I always add a sample parameter in the very first notebook, the one that loads the data. So I can switch that parameter and run the whole thing with a sample of the data. And this is what we call smoke testing. Essentially, we want to make sure that things run. We are not worrying too much about the output, but the very first sanity check that we should apply is my pipeline running? And if you are just checking that things run, then it makes sense to just run with a sample of data. Right? It depends on your use case, but in many cases, it's okay to run with like maybe 1%, 5%. So let's see how we do that. We only have to make a small change, and we have to add a new section to our task. We add params, and below that param section, you have to add the indentation here, so don't forget that. And then sample equals true. Let me do that, and then you'll do the same thing. So let me go to my pipeline YAML, load, and then params. All right, so I added this new parameter, and then let me close this and open load.py. And just as I showed in the previous example, when we were answering the question, you'll see that I now have sample equals true in my injected cell. I didn't have to add anything. Ploomber grabs the value, puts it here. And now let me run the pipeline again. And since I modified the first notebook, it has to run everything again. And now I'll, once it finished executing load, so I'll open it. You see that the output notebook also has sample equals true. But I'm not using the parameter. So I'll go to my source, which is in material, tasks, load. I won't add any logic to sample my data. I'll just add a print statement. So when I re-execute this, this is going to print the value of my parameter. So I'm running Ploomber build again. And let's wait for the load notebook to execute. So, okay, it's done. Let me go again to material output load. Okay, it says sample is true. Now let's say we want to change the value. So I'll do it from the command line. That's convenient. Every parameter that I expose, I can switch it from the command line. And I'll execute only the first task because this is executing everything. And this allows me to show you one new command. So I'll do Ploomber task load, and then I'll pass this double dash and then env. This is the prefix for each parameter that I expose, and then double dash the name of my parameter sample, and then I'll say false. Since I'm running Ploomber task and not Ploomber build, let me see. Looks like it's not recognizing my, oh, I know why. Before I expose my my parameter as an argument, right now it's just hard-coded. So I just put sample equals true. That's why I cannot switch it. So the way to switch it is I need to create a new file. So if you only want to change your parameters from the pipeline YAML, you can just do it this way. But the most flexible way is you create a new file and do env.yaml. So you see I have a new env.yaml, and then I say sample true. And then I go back to my pipeline YAML and I change this for this placeholder. So you see I have a placeholder here. And that's the only change that I need to make. Now, if I come back and say Ploomber task load double dash help, it will show me which parameters I'm exposing. And you see this one. So now I can come here and say env double dash sample false. Now let's wait for it. And let's open the file. Output. Great, sample is false. Okay, so now this is your time to learn how to do this parameterization trick. So if maybe you did it already, but if you didn't, please make the same change. So add these params sample true to your pipeline, and then modify load.py to print the value. Make sure that works. Then create the env.yaml. So the same thing that I did. I'm actually going to show you how they look like. and then make sure that you are able to change it from the terminal. So I'll show you my env YAML and my pipeline YAML. And I added the solutions for the exercises in a new folder, but please try to work on them. And then if it doesn't work, let me know. But you have the solutions here. So let's give 10 minutes to work on this and maybe run a few commands that I ran earlier. And feel free to raise your hand if you need help from me. Or if you have any questions right now, you can also ask. And if anyone got here a bit late and missed the first maybe 25 minutes, we didn't change anything besides if you go to workshop.md, make sure you have the latest commit in the repo. The only thing that you have to run to get to the same point is the very first command, surgeon refactor. And then you can work on the parameter thing. Okay, we are gonna start the second block. So this is going to be another full hour. And we are gonna see some advanced features. And we are gonna start modifying our pipeline to add new things. And I'll show you how to create many tasks without much effort. So you can run the same notebook with, let's say, 20 parameters at the same time. So, all right, let's start. So up until now, we used the existing notebook, and that gave us the pipeline YAML, but we didn't create any new tasks. We simply added a new parameter, and I think that was it. The rest was left as is as the output from the initial command that we ran. But at some point, we may want to incorporate new tasks in our pipeline. Our project may grow in complexity, or we may break down existing notebooks into multiple pieces. So we have to edit the pipeline.yaml manually. And that's what we are going to do right now. So here I have the example of how, essentially a template of how we add new tasks to our pipeline.yaml. There are only two requirements, two sections. Just give me 1 second. Okay, so two required sections for a new task. You can see that I have source, and here I need to put the path to the new task. So far, we've been working with PY files. I also mentioned that this works with IPyNB files. I'm not going to show this for the workshop, but we also support functions. So you may have functions as tasks. You may have a mix of functions and scripts or notebooks, and you can even use SQL scripts. So in like a real world pipeline, maybe a machine learning pipeline, maybe you have 20 tasks, 5 of them are SQL tasks to get data from the warehouse. Maybe some of them are functions and some of them are scripts, so you can combine them depending on your taste or what's required. And you can read all of this in the documentation, but you specify the source here. In this case, it's a path to the file. And then the second section is the product. So these are the outputs that we are going to generate as part of the execution of the script, in this case, or a notebook. Scripts and notebooks work in the same way. Functions and SQL scripts work a little bit differently, but not so much. Now, let's talk about scripts and notebooks. So I said you specify the outputs that you want to create here, and then you take those paths that you specify here, and you make sure that you store those files there. The only output that you specify but you don't create is this NB, this one. this is automatically created by Ploomber when you execute the pipeline. So I'll mention this again because it might be a bit confusing, but we have two files that have the same source code, right? So in the materials tasks folder, we have a load.py file, which is the one that we modify. That's our source code. But when we run Ploomber build, we get a copy of it in material output load IPNB. So that's the path to this notebook. So remember that we have this output notebook. And the one that if we want to modify the source code, we go to tasks. If we want to see our results, we go to output. And that's pretty much it. Those are the things that you need in order to create a new task. So I'm gonna add a new task to my pipeline, and then we'll add a bunch of code, and then you'll do the same thing. Okay, so let me go to my pipeline YAML. Okay, so I'm in my pipeline YAML, and I'll create a new task. So first thing is I need a single dash here, because this is a YAML file, and this dash represents a list. And I'll say source. I haven't created the file yet. I'm just specifying where that's gonna be. So I do tasks, and then let's call this fit. And just to show you that this also works with notebooks, I'll do IPNB this time. And then product. And then remember the indentation. So I'll add 2 spaces here. And then I'll store my output notebook in the output folder. Output, and then I'll call this fit. And I'll show you a new thing here. So I'm gonna change the extension. So I'll do HTML. So the same output, just with different format. Okay. Now I go to my terminal. I'll make sure that you are in the right, I'll give you time to do this, but if you are following me, make sure you are in the right folder, the one that has the pipeline YAML. Now I'll do Ploomber scaffold. So what this command does is that it's gonna run through your pipeline YAML and check if there are any files missing, and if they are, it's gonna create them. So that's just a convenient way to create new files, because it can be a py file, IPNB, function, SQL script. And Ploomber is all about saving you time. So we don't have time for creating files because we got more important things to do. So we run Ploomber scaffold. All right, created we need one new task sources. So if I go to tasks and I see this new fit IPNB. Okay, so now this is like you creating a new task, and the first thing that comes to your mind is what do I need to use as an input? And you remember that you have this trained test split task. And if you are gonna fit a new model, then you should use that one. So I come here, and when you run Ploomber scaffold, this also creates like some commands, some comments with pointers. And I'll change this upstream equals none to a list that says train test split. So I'm saying, hey, I want to use that one as an input. So I click on save, or you can click here as well. Now I come to file, reload notebook from disk, and you see that I have the injected cell. Right? That's if you are using Jupyter. If you are using VS Code or PyCharm, you have to run the other one, the Ploomber and NB inject. But we don't have to run this one here. So let me go back to my fit IPNB, and I can start running things interactively. So I can run my thing. It doesn't have anything. So let me put this here. I'll close a few things here. And let me find my linear regression notebook, because I'll be copy pasting a few things from there, so I don't have to remember what I was doing. Okay, so the first thing is I'm gonna load my input. So I'll just copy this cell, and you can do the same thing. Just open the linear regression file and then copy the code. We are just gonna make a few changes here, but for now, let's just copy it. And you need a few imports. So let's get this here. And you can see that I have my data loaded here. I can print. So this is why I like notebooks so much, because I don't have to think too much. I just print variables and tables, and then I clean it up later. And then let's get this model here. And then let's fit that model. Let's make some predictions. And then let's create a plot. Okay, that's it. We added a new task to our pipeline. Now let's see the diagram again. Let me open a new terminal. Ploomber plot. So we see the new diagram with the new task. I'm not in the right folder. Okay, so I open pipeline HTML, then click on trust HTML, and you see the new one, right? And it's parallel to the other ones, meaning I can now run these three in parallel. These three, they only depend on train test split. Let's go back to the workshop notebook, see what's next. Okay, so now it's time for you to add this feed.ipynb or feed.py. It's the same. So remember the steps, right? Go to your pipeline YAML, edit it, add a new task. Let me show you my pipeline YAML so you see how it looks. Add a new section, then open the terminal, go to materials, run Ploomber scaffold, open that file, and then copy paste the contents of linear regression to that one. So I'll give you, let me see how many things we have for this section. I think this is going to be short, so I can give you more time for the exercises. Yeah, okay. Let's say 10 minutes for finishing this part. And if anything isn't working, raise your hand. Okay, looks like we can get going. All right, so I briefly mentioned this at the beginning, but I forgot that I have a diagram, so I'll restate what I mentioned. Ploomber keeps track of your source code, so whenever you modify one part of your pipeline, it will only execute that one and any dependencies that come after. This is extremely useful when you are doing rapid iterations, but also when you are running things in the cloud, and that's actually the last part of the workshop, running this thing in the cloud. Because cloud computing gets expensive, especially if you are using GPUs. So if you can save some money and some time, that's great. So here I have a diagram. It's actually similar to the pipeline that we've been working on. This example pipeline has two branches. It's loading two different data sets, like load data and load another data set. Then I'm cleaning that data, actually both data sets, and then I'm training my model. So let's say that I modify clean data. I maybe just add a few lines or change the parameters. If I rerun Ploomber build, I won't run load data or load another or clean another. I'll just run the file that I modified and then the one that comes after. This is really useful, especially when your pipeline grows. Like if you have 15, 20 tasks, and you can run 3 or 4 on a given change. That's going to save you a lot of time. So just to exercise this part of what I just explained, we'll do a really quick exercise. So maybe, let's say 5 minutes. It's probably going to take less than that, but let's say 5. Please go modify any of the tasks. Anything that you have in your pipeline, just add maybe a print statement at the end or the beginning. Then go back to your terminal and then execute the Ploomber build. So I'll show you so you see how this works. Let me open, cannot see my tab bar. Okay, I'll go to tasks, fit, and then I'll add a print statement here saying, hello again from SciPy. And I save this. Let me see if I can fix this thing. Well, looks better. So I'm in fit.ipynb. And if I go to my terminal, and I execute Ploomber build, only fit.ipynb will be executed. So make sure you see, actually, I probably modified something else. That's why load is running. So let's finish this run. I'll go back to fit.ipynb, modify something again, and rerun Ploomber build. So this is the good thing, right? We don't have to keep track of the dependencies or anything. We just come back and run Ploomber build. Okay, so it's almost done. All right, so executed everything. Probably I modified something and I forgot. So I'll just add something else. Store and re-execute Ploomber build. Okay, now it's going straight to fit. And you see the summary here. It only executed fit. So make sure you see the same thing. You go modify fit, run again, or you can modify other tasks as well. And you should see that only a few rows from this summary table have this run true. And the other ones should be as false. So let's give 5 minutes. And you can practice, like maybe modify a few. And then we'll come back to see testing. Now let's talk about one feature that's pretty nice to make sure that the pipelines have high quality data, which is always an issue, right? Real world data has tons of problems. And Ploomber allows you to add certain rules to make sure that whenever you run something that doesn't meet the expectations that you have about the data, it complains. As you can see, Ploomber complains about pretty much everything, but that's actually a good thing, so we don't make mistakes. So let's talk about data quality tests. The idea here is that at every step in your pipeline, you can define some rules about what are the expectations about that script or function or notebook. For example, let's say that you are getting data from a warehouse or maybe some raw data that you got in a CSV file or any other format. And you know that maybe your model doesn't work with empty values like NAs, or maybe you have, let's say, a column that should be numeric value and should be positive. That's also something that you may expect from your data. If you don't have these rules in place, you'll end up checking manually these over and over again. And I can give you a concrete example, something that happened to me at work. I was working with financial data, and I was getting essentially portfolios from the clients at the company that I was working. And at some point, they had, I think, some migration in the database, and I was getting data that I should not use for my project. and I completely forgot. And it was actually pretty easy to detect those records. And I had a model in production, and when I rerun my pipeline, my model looked pretty amazing, and I was really skeptical. So lucky me, I took a look at the model training script. That's how I realized that it was amazing. I felt really good at the beginning, but I was really skeptical. So I went back to my data, and it looked really different. Like the distribution of the y variable looked really, really different. And I didn't believe so, because how can the distribution change in like 6 months? That doesn't make any sense. So anyway, I had to spend like 2-3 hours debugging, talking to people who knew the data, and then I realized that I had records that shouldn't be there. So I had to read. Lucky me, I didn't deploy that model into production. Went back to my SQL queries, fixed the thing, rerun it, and then my model went back to being okay. Not so awesome, but still okay. And then I learned that lesson, and that's how I ended up implementing this thing in Ploomber, because I needed a way to put those checks in place and force me to run those checks all the time so I didn't forget. So that's the idea. So let's do the same thing again. Let's say that we want to make sure that we are loading data and we have some rules about what to expect, right? So it's pretty simple. In Ploomber, we can add a new section called onFinish. And onFinish takes one argument. It's a string, and the first part of the string is the name of the file where we are going to put our tests. It's going to be data underscore quality.py, but we omit the .py for this parameter. So it's only data underscore quality. Then we have a dot, and then we have the name of a function. The reason is that we may have more than one, maybe one function per task. So we may end up with a data quality file that has maybe 10 functions. That's why we have to specify both. So let's say we are working on the load.py, and this is our raw data set, right? So I think once we start working with the data, maybe like a few days after we get a new data set, we have some pretty decent idea about what we should expect about that data. So for this example, this is actually a pretty well-known data set, the housing. I think it's the Boston housing data set. And we have the variable. This is actually a regression that we are training for this sample pipeline. The details are not important, but this is the y variable. This is the value that we are predicting. And one simple rule that we can apply is that we should not accept NAs. This is just a rule that I came up with, but you can define your own. Maybe you can accept, or you can tolerate up to 5%, or you can have any other rules. So this is like open, and it depends on your data set. And then we define a function, and this function takes a few parameters. You have to put the same names. So right now we have a product variable, and when you have a product variable in this function, Ploomber knows that you mean the output, the output from this task. So essentially, if I have onFinish here, and my source code is tasks load.py, I'm saying if I have product here, I mean what goes here, right? This is actually incomplete because it should have data, because this one has two outputs. So this should be like this. Okay, now it looks better. And the function is pretty simple. I'm just loading the output. There should be df. I'll just fix it so it's consistent. Okay, so I have product, and then I have a df inside. And that's why when I load my data in my function, I am saying in product, then df. So it gives me this path, df. And then I'm reading the file, and then I'm checking that this column medhouse val doesn't have an ace. So this is just pandas functions. So I'll do that. Let's see. Let's go to the pipeline YAML. And then I'll go to my load and say on finish, data quality, no NAs. Unfortunately, Ploomber scaffold doesn't work to create this. We are working on it, so we'll have to go the slow route and create the file. So I'll create a Python file, and I'll just copy paste what I have on my here. You can do the same. I'll give you some time to finish this, so, but if you are following me, you can just copy paste this snippet. I need to rename this, so let's rename. And this is actually going to pass because there are no NAs in this data set. So let's just force this to fail. And I'll just do like race. I'll just force this to fail. Okay. Let's make sure that we got the right names. Data quality, no NAs. Data quality, no NAs. Okay, good. So let's say that we get a new data set. We have our data quality tests, so we don't have to worry about anything. We know we have our tests. We just come here and execute Ploomber build again. Let's see what happens. Interesting. I didn't modify load, so I should force the task because it didn't run. So let me force the whole thing. All right, so it's executing load. Okay, and you can see this is the traceback. So we format the traceback so it's clear to see what's going on, and you can see a summary here. It's saying my load task had some issue, and if I scroll up, I see that this section corresponds to the load task. And if I read the error, it says, oh no, some mistake. So in a real use case, this would be like you have an ace or you have values outside certain range. And this is only telling me that something failed, but it's not telling me why it happened, right? That's for us to find out. Maybe we should be filtering that data, or maybe something went wrong when we were loading. Who knows? But at least we know. Then we find out. In our case, we can simply go here and remove this so it doesn't break. And then let's rerun the pipeline again. And then if there are no NAs in that column, then this should execute without any issues. All right, we passed the load task. So great, we have our first data quality test. Let's go back to the, okay, so now exercise. Please repeat the same thing that I did. So just to recap, I added a new section to my load.py called onFinish. And then I created a new file called data_quality_py with this content. Now, if you run it again, remember to pass the force flag. So you run the whole thing, Ploomber build double dash force. It should pass because your data doesn't have an ace. Then go back to the data quality, just as I did, and just raise some issue. Run it again. Oh yeah, sorry. I think I didn't explain that. So I was mentioning that where's my file? Okay, here. We have the incremental builds, right? So if we modify some file, then it re-executes. If we, let's say you run Ploomber build, next time you run Ploomber build, it won't run anything. So what we are missing, and that's something we have to implement, is detect if you added a new quality test or modify the quality test. Because right now, Ploomber doesn't know that we have a new quality test. So it's like, you haven't changed anything, so I won't do anything. Yeah, exactly. Well, you cannot define where to start, but you can define where to finish. For example, if you have like 100 tasks and you have 10 nodes, so let's say you have something like this, but instead of one, you have 10. Maybe you only care about one, and you can figure out what to run, but I want the results from this one. And you can do that with partial build. Build. I think it's partially. Let's do double dash help so I remember. Yeah, partially. And then it will run until it finishes that one. Yep. Okay, so yeah, please create your data quality task, and I'll give you 3 more minutes because we have to cover the debugging section, and then we'll have another break. So one thing that I forgot to mention in case anyone's stuck with this exercise is that data quality should be in the material folder, not inside the tasks folder. Is anyone having issues, or can we go to the next section? All right. Okay. Ido. Oh, okay. Sorry, can you repeat the question? Oh, why should be in the material folder? It's because the way the pipeline YAML imports functions. So it looks up in the folder where the pipeline YAML is. That's why. If you put here tasks, should work. Or I think you have to create the init file. I'm not sure. I think it depends on your Python version. Okay. So I'll be quick with the next one, and then we have a break. The next one is debugging. So when developing Ploomber, we spend a lot of time thinking what can go wrong, because most of the time things go wrong. So I think it's important to have a good experience when things are not working, and data usually has a lot of issues and models don't work and things break. So we have a simple feature that allows you to debug notebooks. We are still working on improving things, but we have this simple way of debugging. So let's go to the material tasks load. And then I am gonna copy paste this snippet. So this is a function that divides two values. So takes x, takes y, and then it computes x over y. And here, if you take a look at this snippet, it's obvious what's wrong, right? So I'm computing 1 over 0. But in many cases, when we are working with real code, we have so many functions, or we are loading data sets and things break, and we don't know exactly what's going on. So it's important to know how to use the debugger. So Python comes with a debugger, and Ploomber integrates with that debugger, so you can quickly start the debugging session at this specific task. So let me copy this. And I'll just paste this at the end. Okay. Now I'll go to my terminal, and I'll show you, before I show the debugging thing, I'll show you the interactive console, because it's also pretty useful for other things. If you do Ploomber interact, Ploomber will load your pipeline into memory. So in a Python object that you can explore and you can use for debugging. For example, so it finished loading, and now I have this DAG. And this is the Python, the internal representation of your pipeline. And it behaves kind of like a dictionary. So if you do list, you're trying to force this into a list, it will print the values, the tasks that you have in your pipeline. And there's a one-to-one relationship between the commands that I execute in the terminal, like the bash terminal, and the ones that I can execute in Python. I can do DAG status, and I'll get the same table. Actually, when you execute the command line, we are running these methods in your DAG. You can actually run it from here with DAG build. You can plot. One of the important things that you can do is to get tasks in isolation. So let's get load. I need to pass the name, and this returns me an instance of a task. So I'll do task equals DAG load. And now let's say I want to debug this thing. Maybe it's breaking, and it's actually breaking because I added this divide 1/0 thing. So I'll do task debug. And now we are in a debugging session. Now, you can check out the documentation later, but essentially a debugger accepts a few special commands, so you can go line by line and move between different lines of your code. So we know that things are going to break here, but let's assume we don't know exactly why. So I can enter next, and this will take me to the next line. So check out that I'm in the line number 20, and if I type next and then type enter, it takes me to 21. Now it remembers the last command that I put, so I can keep just putting enter, 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 and that's what I'm gonna do. The import statements are taking a few seconds, but let's say I'm investigating why this is breaking, and so far so good, nothing's breaking. And now I come here, and I know that this is gonna break. So if I do next, it will just run and break. So I'm gonna use a new command and do step. And step means go inside the next level. In this case, level is the function definition. So I'll do enter. And now you see it took me from line 73 to line 70, because that's the function, that's the line that it has to execute next, because I'm calling the divide function. So it took me back a few lines. And now I can use next. And now I'm in line 71. And the good thing is that here I can print the values of my variables. So I can do x, 1, and I can do y, 0. So here's like easy to understand what's going on. But if you have like 10 variables, or you are calling functions inside functions, then using this next step, and there are a few other commands that I'm not going to show today, you can debug things pretty easily, or at least it's easier than if you do print statements. I sometimes do print statements, but sometimes it's a bit more difficult, so I use the debugger. And here you may say, okay, I understand what's going on, 1/0, that's breaking, so now I can go back to my source code and fix it. If you want to exit the debugger, you can do quit, and you go back to the initial state. And you can restart a new debugging session if you want. Or you can start a debugging session for any other task. So we are a bit over time, so we are going to start the break right now, 10 minutes. But if you want to stay to run the debugger thing, that's fine. If you have questions, I'll stay here. So we'll start again in 10 minutes. So 10:20. All right, we'll continue. So this is going to be a bit shorter, like 45-minute session. May take even less than that. So far we've seen that given that we can execute our pipeline with the Ploomber build command, it's easy to just modify things and run. Now, many times we want to go even further and automate, like have a full automation to make sure that the pipeline runs. In some cases, it's a bit difficult because if our pipeline, like in many cases, we are dealing with big data sets and maybe our pipeline takes a few hours to run or maybe even more than that. So it's not feasible to keep running it every time we want to test. So I'll just briefly explain how software engineers do this, and then we'll see if we can adapt this idea to this pipeline thing. So there's something called, first, there's something called testing, which means we are going to write another program that verifies that the original program works. And for example, we may have a function called add, and it takes 2 arguments, and then it adds the 2 numbers. So if we want to test that, we may have some input test cases and check that calling add with 1 and 1 returns 2, 2 and 3 returns 5, and maybe we come up with a few more. And then we can call a command to run those tests, and we may have like 20, 50, 60, depending on how complex our code base is. And since we want to make sure that our code runs every time we modify it, or maybe you or anyone in your team, you want to run that every time, right? And usually these are called unit tests. They only check a small part in our code base. These are like easy to run. They can run pretty fast. The main challenge here is that in the pipeline world, these things don't apply that much. Well, we can of course have unit tests, but the important thing is to test with real data. So we are kind of in a comfortable situation that real testing means testing with production data, because if the data changes, it may break our pipeline, so we want to know. But also, we want to test continuously, but our pipeline maybe takes a lot of time to run. So, it's a kind of a difficult situation to be in, and that's why I think we haven't really figured out what testing for data science means. But let's take a stab at this and see if we can come up with some simple stuff. Now, if you are using GitHub, there's an easy way for you to run your pipeline and actually run any command that you want whenever you push or someone opens a pull request. And a pull request is just someone else wants to contribute to your code, and they present the changes, and then you decide if you take them or not. And as part of that process, you want to test their code to make sure that it doesn't break your project. And GitHub has this feature called GitHub Actions. It has many things, but what we want to do is to run some command whenever someone either pushes to the repo or opens a pull request. So you can see, you can read the documentation to get all the details. I'll just quickly mention what's going on here. This is another pipeline, this is another YAML file. And the way to tell GitHub to run this whenever you push to your repo is to put it inside the .github folder, then workflows, then put any name you want. In this case, it's testing YAML. And I'm saying I want to run this every time I push or open a pull request. Then this is just some configuration saying I want to use Linux. You can also use Mac or Windows. And then I have a few steps. These are pre-configured steps that I can use, so I don't have to install Python or like do many things. So this is just like boilerplate, these few lines. And then I just install the dependencies, and I say pip install R requirements, and then I move to my material folder, and then I run Ploomber build with the sample parameter. And look that I am not checking any output. It's not like I'm verifying, well, except for my data quality tests, right? So that's a good thing. My data quality tests are gonna run here. But apart from that, it's good if I can add more data quality tests, the more, the better, but right now I only have one. And my recommendation here is that you add this sample parameter, because it can detect many things. Like, I can tell that when I was working, because I'm doing Ploomber full-time now, but before that, I was working as a data scientist. But I would say that in 90% of the cases, these pipelines break because you missed one dependency, or the Pandas API changed, like something really simple. And the consequence of that simple thing is to break your pipeline. You don't have to check your output. You don't have to do any fancy stuff. Just run your pipeline as often as you can, and you'll find a lot of things. Now we can get fancier than that and start doing things like more data quality tests, more unit testing. But believe me, this simple thing helps you a lot. And also what I realized is that running with a sample of the data helps in most cases. Because maybe if you're training a model and you're training with 5% of your data, your performance is not going to be as good as with 100% of your data. But if you are using a column that doesn't exist, that's still going to break. So most of things are still going to break. And running your pipeline is not going to take as much time. So I recommend doing this. This is called smoke testing. We are not testing the output except for the data quality part. That's called data quality or integration testing. It has many names. And if you're not using GitHub, if you're using GitLab or something different, then you'll still have the same features, except the configuration file will look different. Now, if you forked my repo, you should be able to create this file. So this is an exercise. Please create this .github workflows testing YAML file and then put the contents of this snippet there. Then create a new commit and then push to your repo. Now, maybe if you don't have the fork, if you only clone my repo, you won't be able to push, but that's fine. It's not a big deal. I can show you how that looks like if you do it. So let me go back to my folder. Actually, we cannot see it here, but let me go to my terminal. And let's go back to the root folder. And you see that I have this GitHub folder and then workflows. So I have the same thing that I just explained, same content. And then let's just modify one simple thing. Actually, let's commit the changes that I made. Probably just the data quality and the new parameter. And then I'll just commit the changes and say changes from workshop. And then I'll push. And now let me find my repo. Okay, let me zoom in. And if I go to the Actions tab right here, you'll see that something, oh, I see someone open a pull request. That's great. This is, you see this like yellow thing spinning? This is my change. So what's happening is I push to my repo and it's going to run my testing.yaml. And we'll see the smoke test thing here. And if we click here, oops, now it took me to the wrong place. Let's go back. Okay, cool. So now you see it's running my pipeline. That's good. Now in a real use case, it might need more setup because you may be loading data from an external place, or that's usually the first thing that you have to do, get your data into this system so you can run your pipeline. Or you can run with synthetic data. That's also another possibility. The problem is that this synthetic data might not represent accurately how your production data looks like. And when I say production, it's your like real data. It doesn't have to be anything that you are like running in production. So that's how it works. You see that I have this green thing going on here. It means everything's working. Now, on purpose, let's make this fail and see what happens. Let me make the data quality test fail. I think I didn't commit all the things because this should break and it didn't. So I'll probably miss some of the changes. Let's actually take, so another useful thing is that we can check the actual source code, because we can go to actions and then see main, and then we can look at the code. Oh, I see why. So let's debug this thing. It's a good exercise. You see that this is supposed to fail and it's not failing. So let's actually see what we are running. And now I remember that I'm running from a specific folder. I'm actually running the solution for exercise number 5, not from material. So let me fix that. Thanks. All right, so let's go to our exercise material, exercise 5, and then I'll make this fail. So the right folder. So let's simulate data quality error. So this is what I'm going to commit. You see the, no, not this one, wrong file. All right, good. So I added one new line. I'm essentially just raising an exception to simulate that something went wrong with our data. All right, let's push this. It's going to take probably like a minute or so to reach that point. Did I push? Oh, yeah, okay. So same story again. I created a new commit and now I pushed and I just need to wait. This is also testing other things because it has to install all the requirements. So something that happens very often is that we forget to include some dependency. And then we may have like a 2-month-old notebook that it's really important, but we never documented the requirements. And then someone tries to run it and it's completely broken. So if we keep running this thing every time we push to the repo, then we'll know. If it's not running, then we should fix it. And then it's just like a sanity check. If these things are running, then it's a good thing. If we don't run these often, then we risk ourselves having issues like missing dependencies or. So you mean changing it locally? Yeah, it's the same thing. You can use Jenkins. So anything that allows you to run something when you push, it's pretty much the same thing. Yeah, it just changes the configuration file. Okay, so we see here that run pipeline failed. And if we look at the traceback, you see breaking things on purpose. So it's not good that it's failing, but it's good that we were able to see this example. So that's it. That's it for this first part. Now it's your turn to do this thing. So please let me find the right file here. So please create, now remember that this is only gonna work if you forked my repo. If you push and you see an error, it's probably because you clone it. That's fine, no big deal. So if you fork it, please create .github/workflows/testing, and then put this content there, push, and then open your fork, and you should see something going on in your actions. So if you go to your repo, your fork, you go to actions, and you'll see something here. Otherwise, it will look completely empty. Now, let's see how we are doing with time. So we have to finish. Okay, we have enough time. I'll give, let's say, 10 minutes to do this thing. Now, if anyone has any questions about any previous sections or issues or anything in general, feel free to ask now. So we'll continue with the, so please work on this testing thing, and then we'll go to the next exercise. Or you can actually start working on it. I saw 2 people open pull requests, so you can also work on that. So let's give 10 minutes. All right, we are gonna continue now. It's the same topic, collaborating. Now what we did is we added this automation that allows us to test our pipeline, right? Real simple setup, but pretty useful. Now, collaboration is a big part, especially in real projects. Most of the time, it's more than one person working on the same thing. So for starters, now we have our pipeline in multiple files. That means we can collaborate easily, because maybe someone is working on cleaning data, someone else is training models, or maybe working with a different data set. So the good thing is that we can break down the logic into multiple pieces, and then different members of the team can modify different parts. And that's great, because if we have all the code in a single Jupyter notebook, it might be a bit difficult to incorporate changes, and it's a lot more complicated. So that's the good thing about breaking down the logic into multiple things. Now, at some point, we need to incorporate other people's work in our repo, right? Or in our branch, depending. So the difference is when we say pull request, it means you have a repo and then you have a fork, which is essentially a copy. And then you want to open a pull request, so you merge that code back in the main repo. But we may also be working in the same repo, and then you create branches. So you have the same repo, but different people might be working on different branches, and you still open a pull request. So it's the same idea, except in the first case, in the fork case, you have multiple repos, copies of them. In the second case, you have a single repo. But the idea is the same thing. Now, one of the main challenges when working with notebooks and using GitHub for collaboration is that the IPyNB format contains both code and output in the same file. And GitHub doesn't support that in pull requests. I think GitLab does now, or like pretty recently. But GitHub, which is what most people use, doesn't support this. So if I use an IPyNB file and I modify a cell and I add, this is what I'm doing here in this image. I am opening an IPyNB file, creating a new cell, and just adding one comment. And then let's say you want to merge that in the repo. This is what the maintainer or the owner of the repo will see. Like, you cannot understand what's going on because it contains a bunch of details, and it's hard to see if I should merge this or not. Fortunately, since we are using .py files, it becomes a lot easier because we don't have all these extra format. Now, the disadvantage is that we don't have the output, but that's one trade-off that we have, right? Hopefully, GitHub will implement decent diffs soon, but for now, we can just stick with the py files. So let's see. And I don't want to bash on GitHub's teams, by the way. I'm sure they are pretty busy. All right, let's all right, let's see what's going on here. I see someone 3 people open pull requests. So this is interesting because you can see here that I have a green tick here. That means this person, Ido, opened a pull request and his code passed. So that's good. He didn't break anything. We don't see this here, possibly because they forked the repo before I added the GitHub thing. So that's why it's not running. So now if I come here, I can see that he made changes to a few files. And since we have .py files, I can see the code clearly, right? Even though Ido can edit this from Jupyter Lab, I can still see the code, and I can put things like comment, previewing his code, say Y4, maybe 4.4. And then we can start the conversation about this code and these changes. And then I can, once I add, actually one thing I just recently learned is that you can pinpoint to like a certain number of lines. So I can see, I can just click on this and then drag my pointer. And you see, I'm like selecting 2 lines because I want to point something there. Actually, let me do this with more lines. Okay, so these 4. This is not great feedback, but it works. And then I can just tell Ido that I want him to change a few things. And I can say request changes. Let's get that. Okay, submit review. All right, and then he will get a notification, and then he can address the changes. And this is great because we are still using Jupyter. Now here I see another pull request. Oh, and this is actually pretty useful because this is something that I'm a mistake on my end. So let me explain what you're seeing here. On your left, you are seeing the workshop.empty that I have. And I made one mistake because I had /env /sample. And if you run this, this is going to break. So my mistake. But thanks, Rob, for fixing my code. Thanks a lot. So he realized that we have that issue, and he fixed it by adding the /. So now I can just come here and say approve, and can merge. And that's it. Now we have his code, which fixes the mistake, and that's great. Now if people can pull this new version, and they'll see the fixed thing. Now let's see what's going on here. Oh, this is also pretty useful. Thanks, Brian, for this pull request. Let's see. Okay, yeah, this is nice. So GitHub Actions has certain commands that allow you to do certain things. So I use the cd command to move to a certain directory, but Brian is recommending us to use the working -directory thing, which I think it's good because it's cleaner, and this supports any operating system, right? So if I were testing with Windows, Linux, and Mac, then the cd won't work on Windows. So this is good. So I can come here. And actually, one thing that I skip in the previous pull request is that I can approve running the test. So let's see what happens. Let's run the tests. It's going to take probably like a minute or so. And this allows us to quickly check if these changes that he's proposing are going to break anything. So hopefully not, because it's just changing the configuration. Let's wait. In the meantime, if you are able to open a pull request, that's great. So the way it works is, I cannot, unfortunately, I cannot show it to you because I cannot fork my own repo. But Well, I think I do. I think I do if I have different accounts. Yeah. Well, I have a few other accounts, but I don't want to create repos there. So you can click here, and let's say you go through the different like the configuration, and you click on fork. An easy way for you to open a pull request is just to use GitHub from the browser. So you can, for example, come here and click on this thing to edit online, and you can add a comment, hello or something like that, and then you can open a pull request. I can't remember how it looks like. I think you have to click here on pull request, and then it should look the same. And then you should click here on compare across forks, because this is just comparing within the same repo. And then you find your name here, create pull request, and then I should be able to see it. Okay, something's not working. So let's see what's going on. Oh, I think it's because of the test. Yeah, it's because my pipeline is broken. So that's also something important to mention. If the pipeline is broken, then every pull request that someone creates is gonna break as well, if unless they fix the precise issue that we are dealing with. In this case, the pull request is only addressing the configuration, but I still have that mistake. But anyway, I know that this is gonna work, so I can just merge. And can also merge this. Actually, this is gonna create a few extra files, so I won't merge this right now. So that's it. That's how pull requests work. And just like to quickly recap what what we did is we configured GitHub Actions to run a script whenever we push to the repo. And then once we had that automation, we created a pull request. Now, if you can create a pull request, that's great as part of the exercise. If not, you get the idea. You can modify the code. Now, thanks to the automation that we have, that automation will run as part of the pull request. And then if things are working well, then we can review the code and merge it and add comments. So that's a great way of collaborating. And given that we break down the logic into multiple files, then it becomes easier to maintain. And also, since we are using Py files instead of IPy and B files, we can see the differences in the scripts. Like, did I add a new line? Did I deleted something? That's pretty useful. All right, so let's see. I think we have 7 more minutes. Yes. Okay, so I'll give you 7 more minutes to go through these 2 exercises, like the automation for GitHub, and then open a pull request. So if you have any issues, so maybe you'll have the issue that when doing git push, you'll see an error, a permission error. That's the case. That's probably because you cloned my repo instead of forking. To fork, you can click here on my repo. You fork, and then you'll be able to modify that and push. So yeah, hopefully you'll be able to open the pull request and also to create the automation. So 6 more minutes, and then we'll have 10-minute break. And then we'll have the last block, which is running things in the cloud. So how do we run this pipeline in a larger infrastructure? That's going to be exciting. All right, so we are going to enter the last block. Thanks a lot for your time. I hope you're learning, and this has been fun. So the last part is about scaling up your experiments. So how can you reuse your pipeline? The first part is locally. How can you parallelize experiments, essentially taking each notebook as a template and then running it with different parameters? So there are many use cases for this, but I'll just show a pretty common one and one that I encountered at work, and the reason why this feature exists is that, let's say you are working on a machine learning pipeline, and you want to use the same training set, but for different models. And then you want to see which one performs best. Maybe you are tuning hyperparameters, and then you have some evaluation plots, and you want to compare those plots to see how different models perform. Now, thanks to Ploomber, given that it generates an output notebook, we get all these notebooks for free, and then we can get those notebooks, compare the charts, compare the metrics, and then find out which one is best. Now, in many cases, you want to use the same code and only change a tiny part of it, just like one parameter. And that's the use case that we have right here. We are going to use the same fit.py, but we are going to add a new parameter. And then we're going to pass a bunch of parameters, and we are going to create copies of that task. Okay, so essentially, we are going to do something like this. We have some training data, and then we generate a bunch of tasks in parallel. So how does that look like in Ploomber? We create a new section called, let me enlarge this grid. And then we can pass a bunch of parameters. It can be more than one. In this case, I'm just passing a model, but it can be many. And then it just computes the different combinations. Like if I have my parameter called A with values 1 to 3, and then B with values, let's say 1 to 3 again, then it computes the product of those, like 1, 1, 1, 2, 1, 3, and then it's like 9 combinations. That's why it's called a grid. In this case, we only have one parameter, meaning we are going to create 1, 2, 3, 4 tasks that with the same, and we are going to execute the same file. So let me do that. Let me go back to my pipeline.yaml. And let's make the changes here. So the first thing is I'm going to tell Ploomber to execute things in parallel. And that's it. Now, I'm going to change this fit task. I need to add a name because they'll get different tasks, will get different names. So I'll add name fit dash. There's a way to customize this, but just for simplicity, this will generate fit-0, fit-1 until it finishes with all the parameters. Now let's actually pass the parameters. So I started with grid, and then I passed the name of my parameter, which is model, and then the value. So I'm going to copy paste this so I don't have to type the whole thing. Okay, so this is what's going on. I have my, this is actually a notebook. So I'm going to use this as a template. And then the first copy is going to get this value, then the second one this, third one this, and the last one this. I am not using the parameter yet in the source code. So that's the next step. But right now, I'll show you what happens if we do Ploomber plot. Have a different configuration, so that's why you have to pass this parameter, but you should have, I think you don't need it. Okay. All right, now we see that this pipeline looks different. And now these are the previous tasks that we had: linear regression, random forest, and fit. Now fit disappeared and converted into fit0. So from fit0 to fit3, right? So all of a sudden we have, with the same script, well, actually same notebook, we have 4 tasks, and we can run them in parallel. But before I run them, I have to use that input parameter. Otherwise, it will just create the same output. So I go to my tasks, open fit. And you'll see that it has to select one combination. So it's just arbitrarily selecting the first parameter that I pass. And then I can run things interactively. So let me run this. So you see that it has this parameter. Oh, I deleted my output. So let me come back and execute Ploomber build. So it generates everything up until the, actually, I don't want to run the whole thing. So I'm going to create a partial build. And I'm telling Ploomber, execute everything until you reach train test split, because I need that training set so I can run things interactively to develop my new fit task. And this is running things in parallel. It actually doesn't have anything in parallel because they all depend on each other. So we'll just wait. Okay, now let me go back to my fit. And then this should run now. Okay, great. Now I have my input. Now I need to change this code because here I'm hard coding my linear regression, and I don't want that. I want to take that input parameter, and based on that parameter, I want to instantiate a different model. So I'll just show you the snippet. You can copy paste this, and I'll explain this. I'll explain what's going on here. Let me paste this here. So let me print the value of model. It's a string, and it has the name of the module that I have to import, right? So model sklearn dot linear model dot linear regression. This is exactly how you import the model. So I can do from sklearn import missing one in here. So you can see it's the same thing, right? Now I'm gonna dynamically import this using the function. Now let me see, I'm gonna take that string, I'm gonna split it based on the dot, and I'm gonna leave everything until the last dot on module name, and everything after the last dot on attribute. So let me run this. And let me print this so we see what's going on here. So you see I have sklearn.linear model. And this is like a convention in Python, meaning I'm not gonna use that. So I'll just ignore that. It's a dot, actually. I can print it here. It's a dot. An attribute. Now I'm gonna use import lib, which is part of the standard library in Python, so you don't have to install anything extra. And now I'm gonna dynamically import that module with this import lib.import module. And this is gonna get me the scikit-learn module. So I'll run it. And you see this is essentially the same thing as doing import scikit-learn.linear model, except we are taking the string as an input. And now I get the attribute. And that's it. Now I have the class. Just the same thing as I did here now, but now we are using the input parameter. So I can delete this thing. And let me actually change the name of this variable because it's not a linear regression anymore. For this case, it is, but for the other cases, it's going to be a different thing. So I'll just call it REG. Okay, one thing is this is returning me the class, right? Not an instance. So I actually, let's name this reg class and then reg. And now it works. Okay, now let's run the whole thing and see if this works. I'm gonna remove this last argument. So hope people can see the bottom. Actually, let me clear this. Okay, now I'm gonna execute Ploomber build again. And now we'll run all the fit, actually linear regression, random forest, which are the ones that we already have, and the new ones. It's gonna run as many things as it can in parallel. You're seeing that it's a lot faster. Because since the models don't depend on each other, they can run at the same time. Okay, it finished. Now let's actually take a look at the output and see if we have different models. We can name this, which is probably useful because fit-0 doesn't mean much. We can add the actual name of the model, but for simplicity, I kept it that way. So here we see that this is the output notebook, right? And this is the one that trained the linear regression. And we can see here, linear regression. Let's open fit1. This got the support vector regression. And we can see here that it's printing the other class. The next one has the gradient boosting regressor, and same story here. And finally, the random forest, right? Now, if this were like a real world thing, I could take those notebooks and compare them, and maybe. So one important thing is how different models behave differently, right? And this chart is like really basic thing, but I could compare those. Like, actually, let's do that. Let's take this one to the right, and let's keep this one in the left. I mean, they look similar, but maybe this dot is interesting to you because why the random forest has this dot here and the gradient boosting doesn't have that? Is it noise? Is it the model? Who knows? But it's important that we can quickly generate these reports. That's why the output reports are important. And I generated this as HTML. You can share this with your colleague and ask them, hey, look this chart, and then look this one. This looks different. So this is pretty useful. We also have another package that extracts the outputs and compares things. So essentially to automate this manually comparing notebooks process, but maybe some other time. But that's the idea. You get a bunch of output notebooks, and then you can compare them. You can run them in parallel. Pretty useful thing to do. Now it's your turn to run this exercise. So let me get to the workshop, MD. So now, just to recap, what you have to do is to change the pipeline YAML. The first line that please add a line at the top that says executor parallel, and then change your fit task, which is the one that you added in a previous exercise. If you do not have this, you can edit random forest or linear regression, which are the ones that come already with the existing notebook. And they have pretty much the same code. Then you don't forget to add the name. That's important, otherwise Ploomber will complain. So add a name, whatever you want. I recommend adding a dash at the end, so you have 0, 1, 2, 3 with the dash splitting the name and the number. And then the most important thing is the grid. Then below that, you add the model. This can be any name. Grid has to be grid, but below you can select any name. And then a list of values. Now, this given how we modify the task, this has to be valid scikit-learn models. So any typo here will break your pipeline. And then you go and modify that task and change the logic that creates the model. And let me actually modify this because I skip one important part. So please, if you copy paste the snippet, then take a look at the screen because I'm gonna make a small modification because this is gonna be the class. And then this is gonna be the instance. So it's important that you have this. This is what you have to add to your fit task. So you dynamically import the model, and then you get the object, and then you can call fit on this one. Okay, so I'll give, I think this one involves many steps. So maybe let's see how we do in 10 minutes. Again, if you have any questions, raise your hand. I'll leave this thing so you can see what needs to change. So I'll start a bit early because we don't have much time left. So this is going to be actually pretty easy. I'll just explain a few things about the other open source package that we have, and then Ido will make a demonstration of executing things in the cloud. Okay. So pretty quickly, so far we've been running things locally, which is great in many cases. I think if we are not dealing with very large data sets, we can just get a big machine and run things with Ploomber build, and it's all good. But in some cases, we may want to run things in parallel or get like really large machines. Or another reason is we may want to save some money, because if we have a big machine up and running all the time, can get pretty expensive, especially if we are using GPUs. So we can export our Ploomber pipeline and run it in the cloud without any code changes. It just requires a bit of extra configuration, but we support exporting to Kubernetes using Argo workflows. So we automate the process of generating the app. So for those familiar with Argo, we export the spec, we generate the spec for you. We create the Docker container, we grab your requirements and create the image, push the image, and those things. In simple words, what we are doing for those who are not familiar with Kubernetes or Argo, we take your code and generate an image, a Docker image, which is just like an abstraction that allows us to freeze your code, send it to a different machine, and execute it. Now, we can execute it in different machines, meaning we can parallelize 100 or 1,000 of experiments using the grid feature. Like, that's pretty useful when you execute things in the cloud. Parameterize, send your code to a cluster, and then execute 100 things at the same time. But we also support other backends. Qflow, we also support that. That also runs on Kubernetes. Actually, it also runs on Argo workflows, but it has a few different things. Now, SLURM, we also support SLURM. So I think that's probably going to be attractive for many people in the audience, because we got that request from some researchers. So they were using Ploomber. I think they're doing computational chemistry and astrophysics. So they had the notebooks, and they were having lots of issues to scale that in their SLURM cluster. And they were doing things manually, copy-pasting code from the notebook to a script, and then figuring out how to run those, and then figuring out how to run those in parallel. So we wrote a wrapper. I think it took us like 2 or 3 days. And now they are running things in their SLURM cluster. So that was like a great story. So if you have any requests, like features or anything, feel free to ask us. We're always happy to chat with the community and see how we can help. We also support Airflow. So that's probably more applicable for people working in industry that have this workflow orchestrator. Same thing, we export your Ploomber pipeline to Airflow. You don't have to code anything. We give you the Airflow back, and then you can run it. And finally, if you are using AWS, AWS has this AWS batch service, which is pretty neat. It allows you to spin up machines and shut them down after you run certain script. If you use bare bones AWS batch, it requires you to learn quite a few things. So if you use our integration, we do all the things, submit your jobs. As long as you have the AWS account and a few things configured, it will run your notebooks in the cloud. This is open source. This is free. You can choose whatever backend you want and run your pipelines. We also have a Ploomber Cloud service, which automates all these things, all this configuration, and we have a free plan. And also, we always work with researchers that want to scale up their code. So if you are running into issues with your infrastructure, you can talk to us. We can give you free GPUs, and you can help us develop Ploomber by using it. That's the best way to find issues and the best way to get feedback. Just like use it, break it, and then let us know. All right. Now, since using this, the open source thing takes more time, more setup, We'll show you how to run things in the cloud using Ploomber Cloud, but internally we use our open source package. We just have a bunch of other things. All right, so I'll let Ido run the last part of this workflow, workshop, and he will show you how to use Ploomber Cloud.
So what we'll see now is how Ploomber Cloud works. As Eduardo mentioned, there is a point where we want to scale. We work on our local laptop and we want to scale our experiments, run multiple parallel experiments. For that, we develop Ploomber Cloud. There are instructions in the guide of how getting an API key. I already have it set it in, so I don't need to do Ploomber Cloud set key. And oops, jumped for a second. All right, so what we'll do is, first of all, I'll list the previous executions that I have. So let me clear the screen. And what I'll do is Ploomber Cloud. Yeah. One sec. All right. Let's move this one a bit here. All right. So yeah, it's a bit unreadable that way. Okay. Ploomber Cloud list. And what it do, it lists all of my previous executions. So what I can see now, let's give it a few seconds. We can see there are a few historical runs 2 hours ago, 14 hours ago, and 8 days ago. What I'll try to do now is I'll list this specific execution. And what I'll do is Ploomber Cloud logs, and I can give it the execution. One second, what happened here? Yeah. Then let's copy the ID over here on the top. I think yeah. It broke because of the Zoom, so. And then what it do, it actually brings the detailed execution of what we executed in the cloud. We can see here all of the tasks were executed, 5 out of 5. We can also see what's the actual status of my pipeline. So let's do Ploomber plot. I already have it here in materials. Let's open the pipeline. Let's trust HTML. And we can see it's basically the same status that we had with Eduardo before we actually executed it locally. What we can do now is Ploomber Cloud build. And then it wraps everything into a zip file, uploads it into Ploomber Cloud. It ignores the output because those are files that are relevant to local runs. And then it's starting to build. What it do behind the scene, it goes to our cloud, it executes it through a CI, and then it saves all of the artifacts. What we can do also, and you can do it on yourself, like once yeah, sorry for that, like the HDMI is flaky when I move the laptop. So what we can also do here is we can actually go down a bit to the cloud section. We can also take all of the historical artifacts. So whatever we have in the output folder, Ploomber Cloud saves it locally, and then we can download it into our laptop. So let's do it now. Let's create a temp folder. So make dir temp. Let's move to temp, and then do Ploomber Cloud, download all. What we'll see now, it downloads all of the artifacts, all of the local files, so we can see all of the reports, the outputs, the products. And that way, if we want to compare, for example, one grid experiment to the other, or different models, that's the way to do it. If I'll go here, let's go to outputs, for example. Then I can see, let's remove this a bit further. No, that's the maximum. All right, so I can see like all of the train test splits over here, the pickle files, the actual data if I want to save it. And yeah, that's pretty much how it works. Now you can do it on your own. There is instructions over here on how to get a key. Basically, you need to go over the registration flow. You put the email. There is a cloud free tier where you actually get up to 50 hours per execution per month. What's that? Per day. Sorry for that. And setting the key is pretty easy. So far, we've been working with the CLI. Same for the cloud. You can do set key, set the key that you get from the console, and then you can start building. Besides that, there is a few helpful links in the bottom. So there is the documentation. We put a lot of effort into making it as detailed as possible, API calls. So if you see anything that's missing, just let us know. Of course, like we put a lot of effort for it. It's an open source. So if you can, please show your support, starting the repo, join the Slack community. We have an active community of 20 people, and it keeps growing by the day. Eduardo, anything else?
Oh, yeah, thanks everyone.